In this lesson, we're going to be solving inequalities using addition and subtraction. So first, before we begin, let's think about the difference between an equation and an inequality. An equation has an equal sign. That means there's only going to be one answer. Inequalities. Inequalities can have a greater than or equal to, less than, or less than or equal to symbol. When you have an inequality, you're going to have more than one answer. So let's take a look at a word problem. Our goal here is going to be to write and graph an inequality. The lowest elevation recorded in the United States is negative 282 feet at Death Valley, California. Use this fact to write and graph an inequality that describes elevations in the United States, that describes the rest of the elevation. So let's think this through. If the lowest elevation is negative 282 feet, can you have anything lower than that in the United States? No. You're going to have elevations that are greater than. So our elevation, I'm going to use E to represent all other elevations in the United States, has to be greater than or equal to, because we know that this is the lowest elevation, negative 282 feet. Now this does ask us to write an inequality and to graph. So when you graph inequalities, make a simple graph. I'm going to put three numbers on there, the number that is in the inequality, one higher and one lower. E is greater than or equal to negative 282. There you go. The highest temperature recorded in the United States was 134 degrees Fahrenheit at Death Valley, California in 1913. Use only this fact to write and graph an inequality that describes the temperatures in the United States. So your job is going to be to push pause, write an inequality for all other temperatures in the United States, and then graph that inequality. Okay. We're going to solve and graph inequalities as well. When you're graphing inequalities, let's write this subtitle. Solve and graph inequalities. You're going to solve inequalities the same way that you would solve an equation, and then you're going to graph inequalities using open and closed dots on a number line. So if you have a greater than, well, that's less than. If you have less than or greater than, you're going to have an open dot. And then if you have less than or equal to, or greater than or equal to, you're going to have a closed dot. I'm going to explain why in a second here. Let's say we have x minus 9 is less than or equal to 3. Just like when we're solving equations, our goal is going to be to isolate the variable or get x by itself on the left side of the inequality symbol. To do that, I'm going to use the inverse operation. Inverse operation means to use the opposite operation. So they're subtracting to get x by itself. I'm going to add. See how this becomes 0 on this side? Whatever I do to one side, I do to the other. So x is less than or equal to 12. Now I'm going to graph this inequality. And to graph it, I'm going to use a number line. And I'm going to use three numbers. The original number, one bigger, and one smaller. Because this has an equal to, my graph has a closed dot at 12. Less than means we're going to shade to the left. Okay, think about what this graph is saying. It's trying to show you all your solutions. Our solutions are anything that's shaded. So our solution is 12 or smaller. That's why you have this equal to here. Our solutions is 12 or less than 12. Let's try negative 10 is greater than y plus 2/3. Again, just like solving equations, our job is going to be to isolate the variable on the right side of the inequality. To get the y by itself, I'm going to do the opposite of addition, which is subtraction. Negative 10 minus 2/3. I have to use the rule of integers here. Same sign, sum, different sign, difference. Because we have the same sign, this is actually an addition problem. Negative 10 plus negative 2/3 is negative 10 and 2/3. Be very careful when the variable is on the right side of the inequality. I would start this problem, I would highlight this, I would make extra notes. When the variable is on the other side, on the right side of the inequality, you have to read from this side first. Think about it. In an equation, if I got something like this, I would have read x equals negative 10 and 2/3. I would have not read negative 10 and 2/3 equals x. Okay? Just like when we're reading the equation, you have to start here. Y is less than negative 10 and 2/3. You have to read it backwards, including the inequality symbol. This is a less than. Y is less than negative 10 and 2/3. Look at what I did there. All I did was flip the order and flip the inequality symbol. It makes it much easier to graph when you flip it. Less than is open. The answer to this inequality is anything smaller than negative 10 and 2/3. This time our answer does not include this because this is not shaded. I would like you to try p minus 9.2 is less than negative 5. Also try negative 1 is less than or equal to m minus 1/2. Push pause and try those now. Okay. We are going to write an inequality and solve for these word problems as well. You are shopping for bicycles. The type you want to buy costs at least $185. You have saved $97. Find the possible amounts of money you need to save to buy the bicycle you want. Okay. Let's write an inequality first. I see that bikes are at least $185. That means the smallest amount of money you're going to be paying is $185. So it could be bigger than or equal to $185. Your bike is greater than or equal to $185. But the good news is that you saved $97 already. So this is some information they give us. We still need to write our inequality. What I'm going to do is I'm going to take this left side and I'm going to use it to represent the amount of money I need to find and the amount of money I have. So x is going to be the amount of money I need plus 97 equals the cost of the bike. But this isn't an equation, this is an equality. We don't know if that bike is $185. It could be more. So I'm going to use this inequality symbol. Okay, so now that I wrote an inequality, the money I have to save plus the money I already saved has to be greater than or equal to $185. I can solve. X is greater than or equal to, and I subtract, I get $88. So you still have to save $88 or more dollars to buy a bike. Your turn to try. You are checking in a bag at an airport. Bags can weigh no more than 50 pounds. Your bag weighs 15.8 pounds. Find the possible weights that you can add to the bag. After you're finished with that problem, make sure you write down any questions you may have.